Hello and welcome back how to make a dialog graph. Alright, so before we continue with making new nodes, I actually want to make an improvement to the connection here because I actually accidentally ran into a better way of saving. So first thing we want to do is open the dialog container OS. Let's open that one up. Let me make sure my nodes are in the right place. Should probably have done that before I started, but alright. So in the node links, so the links between the nodes, we're actually going to contain the ports gun as well. So we're literally just saving the port's name. So what about we just call it that instead actually? So that is that would be base port name and string named target port name. I should probably name it output and input instead. Let's do that. Base node. I'm just gonna leave it as it is for now. Alright, we're gonna save that. Go into save and load. So save and load data. And there we wanna go into save edges. And just making sure that my nodes are correct. Alright, yes. So in here we of course wanna save the names as well. Well, the port's name. So we're gonna go port name, and that is the base is equal to output node. Oh no, that's the connection. So we want the connection edge, of course, with the number we are having, and going output dot port name and ended. Then we can duplicate that, go down here, and go name target name, and go input. Oh yeah, input. All right. So exactly what did we do here? Well, we are going through each of the connections that is called the edge, and we will then the current edge we're going through, we will ask it, well, the output one you're connecting to, what is the name of that port, and what is the name of the input, the input you're connected to's port. So we'll literally just be asking what is the name of the port you are connected to, and we will then save that into our system. All right. So now when that is saved in, we can go all the way down to connect nodes, and that is the old way of we will connect all the nodes. So let me just go down there on my nodes as well. Yeah, here we go. All right. So here we actually just want to find all the ports, all the output ports. So we're gonna make a list of port and go all out. Oh, yeah. I don't know why I expected Tillerton Sons there. Ports. So we want to find all the output ports inside this node here. So we are going to go node dot I dot output container, and we want all of the children inside the output container. So that's literally just all the contents. We're going to go children. As you might have noticed right now, this returns the visual elements because a port is a visual element inside the output container. Well, that means that we have to find all the ports. So we're gonna go where, and we're gonna use a lumbar expression where we ask if x is a port, well, then we want this one. However, it is still returned to us as a visual element. So we want to cast it to be a port. So we're gonna go port. And now we'll get a non-error because it's trying to return it to us as a inu that we are not interested in. So we want it to be returned as a list. So we're gonna go and ask it to return this to us as a list. And we now see it all works. So let's just go through what I did again. First, we take all the nodes, and we take the current node we are in. We will then go out to the input container. I can just quickly go in here. Oh, yeah, I saved. So the output container, when it's done loading. Yeah, there we go. This right here is the input area, or this is the output container. This is the main container down here, and this is the title container. So again, input container here, output container here, and title and main container. So we are actually going into the output container here and finding all the ports inside here. Alright, let's return to the code. And that is of course the output container. We are finding all the children, meaning the labels. If we just quickly go back, we will find the text field, the buttons, the label, and the port itself. After that, we'll say, well, we are only interested in the ports, so find out the ports. However, we are finding them as a visual element. So if you hold over, you can see that it is a visual element. Therefore, we say we want it to be cast to a port, meaning we are literally translating it from visual element to port, and that is because port is a visual element. Actually, I think if we go in here, we can see that it is. Yeah, it's the part of the graph elements. As you can see, is the base class for main graph visual elements. So port is actually a visual element. So therefore, we will then tell it that this visual element, we want it to be cast as a port. However, the way it saves all the ports in it is through a enumerator. I'm not really sure why they save it like this, to be honest. But therefore, we can just go to list and it will return the entire thing as a list to us. Just a note, if you just want one port in it, you can go like this. Dot zero. Of course, we need to rename the. So this way you will just find the first one in it. Just a note for that. Alright, so now that we have all our output ports, we need to go to the next thing. Also with this new thing here, we actually we will also have to make sure that the target node is, if that is null, we actually wanna continue. Alright, so what does this do? Well, we are asking if the target container is null, and if it is null, well, then continue pretty much means that in this for each loop, it will just jump over this part. It will ignore this part. And the reason for that is because what we're going to do down here in a short second is, what's it called? We will go through all the ports, and if any of the ports don't have a target, well, that will give an error. So that is pretty much the main reason for why we're doing that. So we will just go through all the ports, and we will go port. And this here, we will actually need to remove this part here now. And we will also actually be removing this entire thing here. Because the new thing we are making should actually do all that for us, automatical. So no, it's a lot of code that you don't suddenly need anymore, and that's pretty nice. Alright, so let's see, what do we need in here? Well, we need to ask if the items dot port name is equals to the container the current container we are in right here. So current container dot j dot base name port. So if that is equals to that, well, then we know that we have found, the connecting line, the edge that is actually supposed to connect to this port. So in here we can then just copy paste this beautiful thing up here. And instead of this, we can just write item. This over here, we just leave that as it is. And we can then delete this one here. And we can actually just delete this entire thing here now. And save. Right now, I do think that will give an error, to be honest. So, because we haven't done the old way, we haven't saved. Alright, let me explain fastly. Don't know if this is going to give an error. At least it didn't break the system. That's something. Alright, so the reason why we didn't delete that yet is because we go in here and go to node lengths. You can see we haven't actually saved the base node yet, so we're just gonna click save. And now you can see we have actually saved the names all the way through. So now we can go back into our code and delete this thing here. And go back into here. And you can now see that it now loads correctly. So if we go plop, it will then load in the script thing. But of course, the most important thing is that when we make this one here and add the nodes like this, is that it can find the correct one to save it into. So let's see, did we do that correctly? As you can see, we did that correctly. Beforehand, that would they would just take the first one and just go like this. But now it knows it's supposed to. It know where it's supposed to be. That was kind of horrible. So that's a little video about how we are going to save the new the new way of saving connections, because that is needed for the next node, the branch node. So thank you for watching and see you in the next video.